So we're still solving equations, but now we're gonna introduce you guys to a few identities which can be used to solve some of these trigonometric equations, okay? The one that you already see on the board is known as your Pythagorean identity. It is one of the most used ones out of all of your trig identities, and that is sine squared x plus cosine squared x equals 1, okay? And so basically, if you're ever presented with a equation, you can use this identity along with the other ones that are on the next slide to replace part of your function to make it easier to solve. Okay? Now, do realize that this identity can be adjusted, can be altered. Okay? So let's say if I wanted to solve for sine squared x, I would get 1 minus cosine squared x because all I did was subtract the cosine over. Yeah? That is basically the Pythagorean identity, just, in terms of cosine. Okay? So I could use this instead. So let's say the problem had a sine squared x. I could replace that sine squared x with 1 minus cosine squared x and then use that instead. Okay? This can also be solved for cosine, and that would be 1 minus sine squared x. It's still the Pythagorean identity. It's just now solved for cosine instead of being solved for 1. Okay? So any of these are fair game to be used. Okay? It still holds true to the original identity. A few other identities, which I said are on the next page, are your double angle identities. Which are here in the green. Cosine of 2 theta has 3 different ways that it could be written. You have 1 minus 2 sine squared theta, 2 cosine squared theta minus 1, or cosine squared theta minus sine squared theta. However, sine 2 theta is only 1, the 2 sine theta, cosine theta. All of these identities are in your reference book. So you don't have to memorize them. You just need to know how to apply them in a problem. Okay? What you see in the red is going to be helpful at some point in time, like later on in this unit. And I just want to kind of go ahead and address it here. Do realize that the square that's in between the sine and the x means that you are squaring that entire quantity of sine x. Okay? It is just written properly in between the sine and the x. Okay? So sine squared x is basically you're squaring sine x. Okay? There's a difference between this was on top and this on the bottom. Okay? So then that's like squaring x and then doing the sign of that. Yeah.
So on the other slide, it said cosine squared x equals 1 minus sine squared x.
Mm-hmm.
Are they somehow related, like cosine 2 theta and cosine squared x?
No, they're not related.
Okay.
So you want to be very careful. So this one just has the 1 minus sine squared x, but this one that does have the 2, but that's for cosine 2 theta.
Okay.
Mm-hmm. So how that will be applied is what you see on the very far right side. Let's say you had sine squared 30 and it asked you to evaluate. Evaluate means actually solve. You would basically figure out, okay, what is the sine of 30 degrees, which is 1/2, and then you would square 1/2 to get 1/4. So that's how it applies. It doesn't work like logs where you can move the exponent down to the front. It doesn't work like logs. It's a square. Okay? So, let's look at some examples. Okay? Let's look at some examples. We're given that sine x equals 3/4, and x is in between 0 and 90. We are going to find the exact values of these 4 that you see on the board. This is where you want to use your identities. to help you find the value of cosine. Okay? Cosine and sine are both in the same identity of the Pythagorean identity, which was sine squared x plus cosine squared x equals 1. Because we know this identity, we can plug in 3/4 for sine x and solve for cosine x. Okay? I am going to use that altered equation for the Pythagorean identity, which is cosine squared x, because since I am looking for cosine, I want to go ahead and get it by itself on one side. And so I'm going to plug in. Cosine squared x equals 1 minus, I'm going to plug in 3/4 in for sine x, and that will need to be squared. From here, I need to solve. What's 3/4 squared? 9/16. What is 1 minus 9/16? Common denominator, 16/16. Subtract your numerators. How do I solve for cosine x? I need to take the square root. Now, when you take the square root in an equation, it's going to be what? Plus or minus. Here, it's going to be plus or minus the square root of 7 all over 4. But because x is between 0 and 90, is cosine positive or is cosine negative? It's positive. So my solution, cosine x, is positive square root of 7 over 4. We were able to find the exact value for cosine using the Pythagorean identity and the fact that we were given that sine x is equal to 3/4. Questions? Let's do B. We are looking for cosine of 2x. Now, cosine 2x, that is an identity, okay? We can't use what we did earlier because 3/4 is not our unit circle, so we can't do anything with that, all right? But we can use one of those identities. Does it matter which one? No, it doesn't. However, if this is a problem when you were working it out and you found the wrong cosine x, you found the wrong part A, and you use it to find part B, you have no chance of getting B right, okay? So, I suggest you use the one that has sine x only in it. Which identity for cosine 2x has that? One minus 2 sine squared theta? Okay. So, if I use this identity of 1 minus 2 sine squared theta, or in this case x, then I won't have to worry about depending on my answer for part A to find part B. Okay? So, I'm going to again plug in 3/4 for sine x because that's what's given to me. And then I'm going to use order of operations to find what cosine 2x is equal to. What do I do first when I do order of operations? The square. What's 3/4 squared? Then what do I need to do? What's 2 times 9/16? And then what's 1 minus 18/16? 2. Wait, you said negative? Negative 2/16, which is a negative 1/8. That's what you said, right? And that is cosine 2x. Questions? I'm using my identities to find the exact values of these trig expressions. Now, sine 2x. What's the identity for sine 2x? Okay, so that is 2 sine x cosine x. X and theta are interchangeable. Okay, now unfortunately we would need the correct cosine to find the correct one of this. Okay, there's no getting around it. Okay, so we know that sine x is 3/4, and we know that cosine x is root 7/4. So then all we do is multiply those. When you multiply the straight across in the numerators was 2 times 3. So this becomes 6 square root of 7. And then what's 1 times 4 times 4? Does this reduce?
Yes.
To what?
3 square root of 7.
Yes.
Where did you get the 2 sin x cosine x? Is that just like a formula?
A double angle.
It was one of the double angle identities. Yeah. So from the previous page. See that one there? Yeah. All right. And lastly, tangent. Tangent 2x. There is an identity for the double angle of tangent. However, you don't need to know it for this class. But you do know that tangent is what over what? It's sine over cosine. So tangent 2x is the same thing as saying sine 2x all over cosine 2x. We found sine 2x to be 3 square root of 7 over 8. And we found cosine 2x to be a negative 1/8. So we can use those answers to find our tangent 2x by doing a little bit of algebra. To get what? Cube change flip. Okay. Yeah, negative 3 root 7. And then that would be the tangent of 2x. All right, let's look at this one. We're given that cosine theta equals 4/5. And this time theta is in between 3 pi over 2 and 2 pi. So what quadrant is that? 3 pi over 2 to 2 pi? That's the fourth quadrant. So remember, the fourth quadrant is sign positive or negative? It's negative. So then you want to make sure that when you solve part A to find that exact value, your answer is negative. Okay? If you make sure you take care of the original sine and the original cosine, their signs, then you'll be fine for the double angle ones as you go. So I'm going to use the Pythagorean identity again because that's the connection I have between sine and cosine. But since I am solving for sine, I'm going to use the adjusted one. That is sine squared theta equals 1 minus cosine squared theta. I know that cosine theta is 4/5. So I'm going to square that, plug it in and square that, and continue to solve for sine. What's 4/5 squared? What's 1 minus 16 over 25? 9 over 25. So sine squared theta equals 9 over 25. What do I do here? Take the square root. Making sure I don't forget that when I take the square root in the equation, it's going to be plus or minus. What's square root of 9? Square root of 25? And this is why I asked you from the beginning. It's sine positive or negative? And it's negative because you're in the fourth quadrant, and sine in the fourth quadrant is negative. Okay, that's why it's always important that you make sure you check out the domain so you have the correct symbols for sine and cosine, and that's also why you don't forget your plus or minus. Sometimes it actually is the minus. For part B, which identity do you want to use? The double angle, the 2 cosine squared theta minus 1, 1. I suggest that just in case we found the wrong sine theta. I mean, we didn't. That is correct. But, you know, for you, prevent any potential uses. So I plug in again. And I do my order of operations correctly here. Solve this out and tell me what my final answer is. What you get? Very good. These are your exact values. Good. Okay. If. Right. I want to do. Well. Okay. All right, you guys try this one on your own. For this particular problem, okay, what you don't want to do is say, oh, well, tangent theta is sine theta over cosine theta, so then that means that sine is 3 and cosine is 4. You can't do that. You cannot do that. Do you remember when I first showed you the unit circle? Here. Okay, I'm gonna clear off all this other stuff, right? Okay. Here, you have your unit circle with your radius of 1. Okay? The x value of the unit circle was cosine, the y value was sine. Yes? Mm-hmm. Now, what is this red figure?
A right triangle.
It's a right triangle. It is a right triangle. The reason why x or cosine is just x and sine is just y is because your radius is 1. Your hypotenuse of your right triangle is 1. So, with that being said, all of these exact values that you guys have been doing from the last 2 examples, you basically were using identities to find the sine, cosine, and everything else. It was originating from a triangle that's inside of a unit circle. So for this particular problem, when you were presented with the tangent, okay, and it said that theta is between 0 and pi, tangent is positive. Which quadrant between 0 and pi is tangent positive? The first quadrant. Because when you're bounded between 0 and pi. So there is some triangle, okay? There is some triangle inside the first quadrant where your tangent is 3/4. Where this is 3 and this is 4. Now, this is not like your exact values where 3/4 is one of the ones on your unit circle. Which means that your radius, your hypotenuse, is no longer 1. It's what now? What is the hypotenuse of that right triangle?
5.
Say again?
5.
It's 5. Pythagorean theorem, 3 squared plus 4 squared, 9 plus 16, take the square root, that's 25 square root. Okay? And so from here, this only applies, well, you have to do it this way when you're given tangent because there is no identity that you need to be responsible for that will help you find sine and cosine straight from tangent. So you'll have to use your knowledge of right triangles and SOHCAHTOA to find sine theta and cosine theta. What is sine of theta? 3 what? 3/5. What's the cosine of theta? 4/5. Don't forget, sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. And now that you have sine and cosine, you'll be able to find sine of 2 theta and cosine of 2 theta. Using the identities. You know that sine of 2 theta is 2 sine theta cosine theta. And now that you have those from A and B, you can plug in. And what's 2 times 4 times 3? 24 all over 25. So that is your sine of 2 theta. And then your cosine of 2 theta, you can use any one of the 3. Considering that the other examples we hadn't used this one, I'm just going to use it for poops and giggles. It's a minus, right? Cosine minus sine?
Yes.
Okay. That is 4/5 squared minus 3/5 squared. Which is 7/25. So let's recap. There's no identity that you're responsible for knowing that's going to be able to be used to get you from tangent to sine or cosine. So then you rely on your knowledge of trigonometry and right triangles and SOHCAHTOA to set up a triangle to find sine and cosine. From there, you can then use your identities to find any of the other ones. Questions?